Okay, so today is supposed to be the start of module 2 based on our program. But I felt that we need to exhaust, or let's use today and summarize everything we have done in module 1. The other option is to do it at the end of the class, but no, let us summarize it today. I'm aware that I gave us a video to watch last week. I wonder how many people have watched it, but if in case you have not watched it, let me just make a recap of what is in the video today. We are going to be doing computer application. We have done the introduction. We have done the first principle. So what happens is that after the first principle, you get your value, you now move into the computer application. One thing I always tell engineers and designers is that no computer can do a design for you as an engineer. What computer does is to model and simulate. Let me say it again. Computer softwares helps you to model your design and then simulate them in some instances. When we say AutoCAD, you draw beam, slab, design. That is not design, that is detailing. Detailing is a 2D model. So what computer does for you is not computer that will estimate the dead load. It's not computer that will estimate the water demand at every session. It's not computer that will determine the population equivalent. It's not computer that will determine the elevation, the pipe size, the pipe length, the frictional factor to use. It is not computer that does those things. It is you, the engineer, that will know those things based on your startup sheet. Then after that, you now get your table, develop your charts. Okay. After you fill those charts, those 4 parameters, you now take the 4 parameters to a software. In our instance, we're using Epanet. Last week, we all downloaded it. We all downloaded Epanet. So if you have not downloaded it, please you download it. And after downloading it, you go to our materials and you see a material called Epanet Exercise 1. Epanet Exercise 1. It is where we are going to use to demonstrate. You know, every writer, every developer of software will always have a material embedded in the program that will give you a head up. So there's a program there called Epanet Exercise 1. We're going to do it. It's a simple exercise done in American units. Then if tomorrow you want to go further and know more, even do quality modeling of your network, there's a big manual called Epanet Manual. It's about 200 pages. But the one we're using today is about 11 pages, exercise 1. We only do exercise 1. If you have time on your own, you can do exercise 3 on case study 2. But for the purpose of this, our online training, we're going to do exercise 1, Epanet exercise 1. So if you are here with me, I would like you to open it. Open to Epanet exercise 1. Epanet exercise 1. So that is a summary, a synopsis of how to use the software to model your system. After you must have done what you need to do, which is basically to generate a table like this. After you must have generated a table like this, and you have filled the Q at every point, the slope at every point, the diameter at every point. So with these 4 parameters, you are good to go. And last week we said those parameters are 2 parameters for pipe and 2 parameters for the node. What are the 2 parameters for the pipe? The pipe length and the pipe diameter. You need to get it, write it down in the table format. This is your calculation sheet. If you're doing any pipe design, you must have a sheet like this. Whether it's stormwater, sewer, or potable water, or gas, there must be a sheet like this. This is your calculation sheet. So this is only for 10 pipe sections. It can be up to 1,000 pipe sections. And Excel is your willing tool to do that. In fact, if you go online and you type Google and said pipe sizing charts in Excel, it will bring you a lot of charts customized by different bodies, by different consultants all over the world. You can use one, you customize it, and you start to use it. So now, if you look at this table now, you will see that we assume that we have filled them. And if you have filled them, then it will look like this. You go to this exercise 1, and you go to page 4. You will see in page 4, the node properties have been given. The node property says elevation demand in gallons per minute. Node 2 has an elevation of 700. The demand at that point is zero. All of us know why demand should be zero. Then node 3 has an elevation of 700 and the demand is 150. Node 4 says elevation of 700. Demand is 150. So you can see the demands and everything. After that, you go down further, you see the pipe parameters. Pipe 1 is 300. Pipe 2 is 500 and the diameter is 12. Look at the pipes here. I forgot to inform us that there might be need for some of us to print these things. All of us are on laptop. But if you're on your phone, it's close to impossible to really follow up because you need to be flipping through two screens. So I think those of us who has our phone around us, you can also open this material on your phone so that you can be looking at the layout while I'm demonstrating. You can be looking at the layout and you can be looking at another sheet. Okay, so now let's continue. So this is what we're going to draw. So if you miss any of the steps, this manual is handy for you, please. Okay, so you see in this manual, we'll simply analyze a simple network shown below. The idea of analyzing this network is just need to have a graph of it. Okay, then just to have a graph of it. So our focus will be this manual. So once again, go to your manual sheet. For those joining us, I just added 5 people now. Go to your folder. Look for Ethernet exercise 1. Open it. Ethernet exercise 1. Open exercise Ethernet 1. Exercise 1. And in this exercise, this is the network we're going to be drawing. We're going to be drawing this network. So if you miss anything, just read through the network. So I'm saying to aid our comprehension, I would like you to open this thing on your phone. Open it on your phone so you can be reading through your phone. So go to the materials. You open it. I've shared the link. Oh, no. Let me share the link again. The link is there. I think I've shared it to all of us before. Those who are joining us might not have it, but I think it's all there. So now, so if you open the material, you go to Ethernet exercise 1. Please open it on your phone. Good. I'm opening on my phone so I can be seeing the thing when I'm drawing. Okay. So you multitask. You're going to work on 2 screens. So let's go. So the first thing I do is I go to my start menu. I type Ethernet. Ethernet 2.0 will show up. Then I'll click on it. So this screen will open. This is the Ethernet interface. So Ethernet interface, you go to the first paragraph, say project setup. Project setup. Like I said, this is the standard way of using any software. So quickly go to project setup. Project setup, you say, first task is to create an Ethernet and make sure static default options are selected. You say if Ethernet is not running, make it to run. You say go to file, create new. Then go to file, then create new. We've done that. Then number 2, under project setup, he said go to project defaults. So I'll go to projects and I'll go to defaults. Under defaults, we want to label the node ID, the ID. So how would the ID show? How would it state the difference between the different components? So look at my screen and write everything I've written. Then under increments, you scroll down, you scroll up. When you scroll up, it says under increments. Under increments. So look at my screen. Just put one under increment. This one under increment means if there are two reservoirs, you put one reservoir one, the second one reservoir two. Pump one, pump two. So the increment is by a factor of one. So just check what is on my screen and just do the same thing while following the manual. Why I want you to follow the manual is that after the class, you can still refresh what you have done so that you have a good mastery of the software. So, okay, so we're on number 3. So you say everything after clicking, then we are under setting properties. Setting property, please just comply as I said. Open the software, open the side of your phone so that the software will be on your screen. I can give you time. I can pause it. Let everybody on the same page. This is very important. This is why we have to repeat this again. I just resumed the recording. So now, remember, you go to projects, go to defaults, and you set your defaults based on what I have done. Gallons per minute, Hezzy Williams, properties, you can leave it, but for me, to play safe, I'll just put 8 inches as my maximum, as my default. So if I forget to put the diameter of any pipe, to assume 8. Then here, I put everything. I click on Save As so that I don't need to create it again. I click OK. So that is that. So it now says we should go to map setting options. So I'll go to View. I'm under map setting option, last line of page 1. The last line of page 1. It says select view. After you select view, you go to map, you go to options. Then number 2, under notation, you click display node ID. You can click the first 4. So I don't have to come back. So I go to my node. I can change the node to 5 just to make it bigger. I go to link. I change it to 2. You can change it to 3. You can change it to anything you want. I go to label. Label is okay. Notation, we have done it. Symbol, leave it. Arrow, I can change it to fill arrow. I can change it to 10 or 7 or 8 just to make it look bigger. We're on page 2 of the manual now. Open the manual on your phone once again. So it's more like you are having a physical manual, but your phone is now serving as that physical manual. Okay, the background, leave it at white. Okay, I'll click OK. Now the next thing is draw the network node. Draw it now. Remember, after drawing anyone, go and click this black. This black means deselect. Once you click this black, you are good to go. Okay, so what's the first thing? You say we should click on the reservoir. You are free to be ahead of me. I click on the reservoir. That is number 1. Under drawing the network node, page 2. So I drop it here. I'll go and click this black arrow. Always, as I draw, only one reservoir I'm drawing, I'll click this black arrow to deselect. If you look at my browser, it has given me reservoir 1. Good. Next, we add the junctions. So if you're looking at the manual, look at what we're drawing, gentlemen, ladies. This is what we're drawing. So after drawing number 1, I'll go and put number 2, put number 3, put the nodes. So 1, 2, 3. And from the number 3, I come down. And
my own is not showing reservoir 1, sir. Not showing only the.
Because you didn't put 1. You didn't put 1. Don't worry. My own is not showing reservoir 1.
It's not even showing the letter. It's not showing the letter, sir.
You didn't do option. Go to options. Go to view. Go to options, and then under notation, click the first 4.
Okay.
Good. Okay. Follow me as I go. If you get stuck, call my attention. Just follow me. Focus attention, like I said. It's something I've done 30 times. Just follow me. Okay. So now, I will click on node.
Hello, sir.
Yes.
Please, sir. Good morning, please. I just joined. You're asking us to open. Which one are we opening on our phone?
You've been in this class. This is already 10:30. From next week, gentlemen, let me make this announcement. By 10 o'clock, I will start the training. If you didn't come on time, you wait for it. Not just because of you, but I'm saying it because every day we're using 10 minutes. But someone will not assume that will be the standard. No. From next week, once it's 10 o'clock, once it's 9:45, I'll open the system. We can start talking. So assume in your program that this program is 9:45 or 9:50. Once it's 10 o'clock, I'll start, because once it's 12 o'clock, I have to close this class. If you don't attend for whatever reason, good and fine. You watch the video. Now, the video is on now already. Go to, let me pause it again. Next, number 2 says we should click on the nodes. I have clicked on the nodes. I'll add one here. 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 That's how it looks like. I'll go and click this black again. Number 3 says we should add the tank. This is the tank. I'll click on the tank. I'll add it somewhere here. We have added all the nodes. The next is the last paragraph, or paragraph 3, drawing the network links. After adding this one, your mouse will be showing action. Please go and click the black again. You must be fond of clicking this black to deselect. Now, so we'll click on pipe. Watch me. I will not click from reservoir to 1, though. I'll start from number 1. I'll click on this one. It will just show me pipe 1, P1. It will disappear. I'll know it has clicked. I'll click on this one to turn to pencil. I'll click on this one. Once it disappears, I will know I'm in order. I'll click on this one. I'll click on this one. I'll know I'm in order. Click on this one. I'll move down. Once I get to the center, I click again. I'll click on this one. When I get to the center, I click again. I'll click on this one. See, it will just disappear. I'll click on this one. Once I get to the center, I click again. I'll click on this one. Once I get to the center, I'll click again. Then I'll click on this one. I'll draw like this. I'll show you how to do that curve later. I'll go and click the black arrow again. If you are just joining us and you are lost, just open the manual. Internet exercise 1. Gradually follow the manual from page 1. You will get it. Many people learn some of these things without any teacher. You just need to learn how to use it. The manual is there. Internet exercise 1. Now watch me. If I click on this black arrow, if this doesn't look well shaped, I can click on it, hold my mouse down. And I'll drag it up. If I click on the center. Good. I can move this reservoir by clicking the black arrow. I'll click on it. Once it's strong, I'll move it. Now, between the reservoir and the, okay, let's continue. Then number 3, the last paragraph in page 3, he said pipe P8 is curved. To do this curve, we use what we call vertex. The first thing I do, listen, some people will always come confused here. You click on this pipe, it will be highlighted. Even if you go to the map browser, you see that P8 is highlighted. Once it's highlighted.
Sorry, sir, my pipe notation is not showing. No. It's not showing. For P1, P2, mine is not showing. It's only the nodes that are showing.
If you go to default here, did you put P here? No. On that pipe, did you put P? You did not. Put your default the way mine is. Put your default, put all your default so that all of them will show. Then after putting it, make sure you go to view, options, notation, and the first 4 are selected.
Okay, I did not select the first 4. That's why. Thank you, sir.
Okay, so you click on this black, you click on this this thing called vertex. Last week I told us that if you want to know anything here, just hover around it. Hover around them, the name will pop up. So go to vertex, you click on vertex. Once you click on vertex, you come back here, you right click on that pipe, and you say add vertex. It will look as if nothing has been added. Click for the second time, you will notice something. Second node will come up. Click again, second node will be added. You can click like add like 4. The first one will not show you. First of all, you click, it will turn to black. You right click. You know, right click in any software is property, it's called menu. Once you right click, left click means action, enter. But if you right click, it will give you pop-up menu. That has always been what it is. So after I added enough vertex, I'll click on one of them and I'll drag it. I want to make a curvature. If it's not enough, I'll add more. This curvature could be a street that is curved. Could be a section that is curved. This is how you build that curvedness.
Hello, sir. I have a question.
Yes.
This, I have done this before, and my vertex is always giving me problem that it doesn't start. Sometimes it starts from the middle and goes towards the left.
You drag it up. You just drag it up. Just for you to get the curvature. You drag it up.
So I can drag the vertex up the point I want it to be.
Yes, yes.
Oh, good. Because it gave me problem when I was doing assignment.
So go to number 4. Now page 3. Number 4 on page 3. You want to add a pump. If you check here, if you click on this map, if you open it and you go to pumps, there is no pump. So we're going to add a pump, and the pump is pumping water from the reservoir to node 1. So I'll click on pump. Look at pump here. Click on pump. You do as if you are drawing a pipe. You click on reservoir, and then you click on the node. The pump will just appear. Then under your browser, you can see pump 1. Show it now. I'll go here and click this black arrow again. But if you click another thing to add another pump,
So please, can you come again for the adding vertex? I can't get it, sir.
okay, you click on, first of all, you highlight the pipe where you want to put the vertex. Once you highlight it, oh, it's even here. Okay, the vertices will show. You now go here and click on vertex. Look at the word vertex. Once you click on this vertex, you come back again. You right click and say add vertex. You must click it for 2 times. The first one, it will not show, but the second time it will start showing.
Sorry, what does vertex signify?
It's for you to be able to draw curvature, curves, curve of any shape.
Okay.
You just to, as you're doing reticulation, to maneuver areas so you curve the way you want it. Once you add it, you start curving it the way you like.
Sir, I want to ask a question. Can you remove the vertex after making your curvature?
No, it will remove it. It will go out on its own.
Okay.
You know what I'm saying? Because my own adding vertices, they are so close together. I can't even adjust. I don't know what's the
Can drag them up. Can drag them up.
Okay.
Use the cursor of the vertex, hold it, and then click it, highlight, then drag it to the point you want.
Are we together? Are we on the same page?
Yes. So go ahead. I want to see how you added the pump in between the reservoir and the node.
A reservoir?
I want to see how you added the pump.
And drop it there. Kick tank and drop it there. Just click them and drop.
The pump. We first of all draw the line.
Click the pump. You click on the reservoir and then click on the next node. The pump will add.
Oh, thank you. Thank you.
So come again, you say click on pump, click on reservoir and line, and it will drop. Okay.
It says click on the pump, then go and click on the reservoir, click on the next node where you want to pump to. Then it will see joining it with pump.
Okay, thanks.
Are we on the same page? Are we on the same page?
Yes. Yes, sir.
Are we together? I want everyone to be here with me. If you are not yet here, let me pause the record. Sorry, gentlemen, keep pausing this down. Any other question?
Hello, sir.
Yes.
My own question is that we were saying before that the tank and the reservoir can be we can take them as the same. Now we have reservoir by the right, left, and tank by the left.
That's how they choose to do it. The idea is that if you pump to the tank, when you shut down the reservoir, water will flow from the tank to the network. Yeah, just like we do in our homes. There's a central reservoir in the estate, but yet we still have our individual estates too. Okay, so can we go to page, we're still on page 3. We have said the property. No, we're on page 3. So we are done with adding labeling. Okay, labeling, we're under labeling, no? Yeah, we're on page 3. Number 4, we have added the pump. So let's go to add labeling. So you go to the toolbar. You can click on T, this T. You now click on here. You can add source. You see? Then the other one has tank already. So you can use this to add a lot of things. This T, to add extra tests or anything that is not there. You can add tests, you can add source, you can add anything that is not there. So we now go to, still on page 3. You go to setting properties, setting the properties. Are you there? Adding properties.
Sorry, excuse me, sir. Sorry, excuse me. I was still working with Expanet 1.
Expanet exercise 1.
Yeah. Okay.
This is it now. We have drawn it. Everybody has drawn it. So next, okay. I'm looking at the manual. So we're going to set the properties now. We're setting properties now. So for the properties, so go to the reservoir. You click on this black arrow always. When you click on this black arrow, you double click on the reservoir. The property of the reservoir will come in. You discover that the reservoir does not have head. So you give it a head. The head is 0. So you put 700 as a head for reservoir. You press enter. If you put any property, you press enter. Okay. Are you with me? We're on page 4 now. First paragraph of page 4. Then you click on node 1. Node 1, the elevation is not given, but the elevation in the manual is 700. You put 700 for node 1. You see why you need pump. The reservoir is 700, the node is 700. So what can push the water? It's pump. That's why they put pump. The base demand, you leave it at 0. You press enter. Then you go to number 3. This is number 3. You double click on it. The elevation is 710. It's 10 meters higher. 10 feet higher, sorry. And the base demand is 150. Okay. So just follow the, this is like the what you have achieved with the table. Remember, we say you have to develop a table. So I want you to assume that you have done your table and you have your 4 parameters. Need to ask.
Please, what's the meaning of base demand?
We did it last week. Base demand is demand at that point. Is the water demand. What previous video you understand it? Is the water requirement of the houses around that node. These are the total demand of the houses around that node at that point. So we go to note 4. The elevation is 700. And the base demand is 150. Enter. You close it. You go to the next one. The elevation is 700. Are you with me? The base demand is 200. It means more houses around that area. Then this last one, the elevation is 650. It means water can flow through gravity from source to this point. We're already providing pump. And the base demand is about, I don't know, maybe 150. Okay. Then you go to this node. The base demand is 0. The elevation is 700. Enter. You go to the tank, double click on the tank. Elevation is 830. Enter. I want to ask a very important question now to all of us. What is the maximum elevation? What is the maximum elevation in this node? What's the pressure in this zone? Who can give me the answer? What is the pressure difference? Or what is the pressure? Or what is the pressure zone? Or what force do we require in this? What pressure do we require in this network? Who can give me the answer? From the table given on page 4. From the table given on page 4. Any idea?
It should be 830 minus 650.
Good. And what is that? 200.
Yeah.
Wonderful. The highest point and the lowest point. But then you are wrong. It will 700, which is the source of water. Did you get it?
Sorry, we didn't hear you.
The elevation of this water source is 700. The elevation of the designated tank.
We didn't hear you.
The elevation of the water source is 700.
That is 130.
Thank you so much. So that is the pressure you need to overcome. That will start giving you an idea of what to provide, what type of pump you need to buy. Because the water from 700 can go to 650. But the water from 700 cannot go to 830. So you need a pump to pump water from 700 to 830. Like I said, this is a different design. This is a customized design. The design is this kind of design. You have it in Nigeria, you have it in Mina. In Mina, where the water source is, and where the tank is passing through the city. So they can't just put pipe and the pipe will be passing. So what they do, they put up tapping points. So they put valves here and there. Are you with me?
Sir, you've been going on and off.
I didn't hear you at the point,
on this last explanation.
Okay, I said, let's continue. The video will be there. I said the elevation of the tank is 830. The elevation of the reservoir is 700. So the difference in elevation is 130. So that means you need to provide a pump that will provide a minimum pressure of 130 in this network. You're not going to provide 130, you're going to provide something more than 130 because of the losses in the pipe. So I'm just giving a head up of probably the next thing we're going to face. Are you with me now? Is that understood?
Yes, sir.
Yes.
So what happens to the 630?
630 is already in line, is lower than
the
reservoir source. So even without pump, water will flow to 630.
Okay.
Due to gravity.
Okay, sir. Why is the tank a higher elevation than the source?
Because once you pump, because that is where you can locate your tank are usually located at the highest point. So that when you stop your pump, water will flow through the network through gravity. That is a standard. 95% of the design all over the world is done in such a way that the elevated tank is located at the highest point. So that once you pump water with energy to the tank, you shut down the pump, then water will start flowing from the tank to every other part.
Okay, thank you.
So my own notations and what is on the tutorial, they are not rhyming. Well, I think no, my own when my own is J1, theirs is 2. I think they use the add label
It
to
doesn't mean
add
no.
those.
Don't worry about that. Don't worry about that. Just don't worry. The thing is going to master it. If I want to change, if I want to change this one now, listen. If you want to change J2, I'll right click on J2. I'll say properties. I'll go here. I'll say Uche node.
Okay. Okay.
But don't let I'll try and put underscore. Because it does not accept 2 words. Are you seeing something?
Yes.
If I want this J6 now, I can right click it. I'll say J100.
Okay.
That's not my problem.
Mm.
So make sure you have inputted all the values, because we are now going to design the pump.
So excuse me, sir. Wow.
Hello?
Hello, can you hear me?
I'm saying the values now. Since my own nodes and theirs are different, I'm just
engineer,
following.
we are learning. Engineer, it must not be the same. The purpose is demonstration, is to make you have the graphs. So when
my hand is up.
And you put 10, it doesn't mean, okay, ask your question, sir.
My hand is up.
Okay, thank you.
Okay, looking at the network diagram, the position of the reservoir in relation to the position of the tank, there are several knots in between the pump and the tank. So when the pump is pumping water, will this water pass through all the node before getting to the tank, or we have a direct?
No, this is how they choose to design. They do the economical design. Like I said, there's only one city I know that has this design. Let's listen. Ideally, you pump from source to reservoir, then from reservoir to network. But these people, maybe the tank pass through the city. So what they did was to say to lay a pipe. So that means this pipe will be a big pipe that will supply the reservoir. And as soon as they shut down the pump with a non-return valve somewhere here, the water will move from the tank to the network. So I want you to allow this network. This is just what they provided for. In our own network, which we did last, it's different. So, yes.
Sorry, excuse me, sir. I have a question, or rather, an observation. Does it mean the same pipe that?
Yes, it is. I know your question. It's the same pipe. Same pipe used in supply is the same pipe used in distributed. Yes. Like I said, it's an economical design. It's not a standard. Don't see this as a standard. Like
okay.
The
only difference is going to introduce a non-return valve.
Yes.
Okay.
To the pump that will not damage the pump or whatever, or that will not flow back to the reservoir.
Okay.
Excuse me, sir. Please, sir.
All these questions is eating to our time. Yes, I can hear you. Ask your question.
Please, I try to add up the pump, but it's not adding. I don't know what's the problem with my own.
Click on pump. You click on reservoir, on the middle of reservoir, and then click on the first node. It will add. Then you go here, you click pump. Check whether there's another pump here. This is pump. I have only pump one, only one pump. Are we okay? Are we okay? So let's move to the next one. Now, let's move. Let's continue. So we're adding a pump curve now. Okay, no, we're on page 4, the last paragraph of page 4. We're adding the pipe parameters. So go to pipe 1, click on this pipe 1, double click on it. You will see the length. You change it to 3,000. The diameter is 14. Oh, yeah, start adding them. So this is 1.
Hello.
For pipe 1, this is my pipe 1. Whether your own is answered on that name, no, it doesn't matter. Then pipe 2, this is my pipe 2. I double click on it. The length is 5,000 feet. Remember, we are drawing in feet. And the diameter is 12. Then pipe 3. The diameter is 10 inches. And the pipe length is about 7,000. Now, you don't need to be accurate, okay? Just look at the table on page 4, the last paragraph.
What you have for pipe 3? What you have for pipe 3 is 8 inches, not 10 inches.
Yeah, but it depends on where you are looking at your own pipe. If you go back to the manual proper, you discover that that pipe is pipe 6. The pipe leading to the tank is called pipe 6 on the manual.
Okay.
In my own case, it's pipe 3. Thank you, sir. Like I said, it doesn't matter. It's just for you to understand it because you have done your own. You correct it. So pipe 6 is 7,000 and 10 inches. You know, also that is why it is 10 inches. We know why, because it's the biggest pipe delivering water to the tank. So it's going to be well sized. That is like maize, primary. Remember last week? That's the primary pipe. It's the one delivering water to the pipe. You cannot use 3 inches, 4 inches. You're going to use like 8 inches to push water to the tank first. So that you can deliver water to the tank within 1 hour, within 30 minutes. Just fill the tank. Then you now shut it down. And why is it reducing in value? All of us know why. Because from 1, it was 14 inches. Then as soon as you take a detour, it reduced to 12 inches. It took another detour. It reduced to 10 inches. But if you look at the other ones, they are now 8 inches, 8 inches and 6 inches. So by 4, for instance, you double click on it, you put 8 inches there, and the length is 5 meters, 5,000 feet, sorry. So add the other ones so we can run it. Only 2 pipes are 6 inches. Whether it's 5,000 feet or 7,000 feet, it doesn't mean, just put something there. I'm done. Who is done, please?
Sir, I have a question, sir.
Go ahead.
Sorry that I will just take you back a little.
But don't take it too much.
Okay.
Anything you don't understand, remember there's a video backup.
Yes, it's okay. The pump, sir, you said that the difference in the elevation is what will determine the size of the pump?
Yes.
Okay.
Because you need water to pump to the tank. And the pump starts at 830, while you are standing at 700. So you need something of 130. Push it up there without frictional losses anyway.
Okay, thank you.
Are you there? I'm waiting. If you are done, say done. If I just see 5 people done, I'll know. Make sure you don't miss any pipe. pipe parameters, two pipe parameters, two node parameters. That is the crux of the matter. You must put two parameters for the node and two parameters for the pipe. Once you achieve that, you have finished the design. And those are the pipes you're going to detail again in your final drawing. Two people say they are done. Who again is done? Page 4, last paragraph. Put in those 8 parameters. After you are putting in the parameters of paragraph 4, of the first paragraph of page 4, we are still on page 4. 2 tables of page 4. You put them. Those are the same 4 parameters that we did last week. Length, diameter for the pipes, elevation, and water demand or discharge or flow for the nodes. To design the pump curve, if you go to the pump, you see pump. So every pump runs with the pump curve. So you go to pump, you go to curves. You see, there's no curve there. So you click on this symbol, add. It will bring up something and it will give you curve ID 1. The flow, the maximum flow we have in our network is about 200. So let's go with 200. Let's go with 600.
So sorry, take it again, please. I didn't follow from the beginning of this one.
If you come to your browser, you click here, you go to curves. You click on curves, pump curves. Curves means pump curve. But to shorten it, they just write it curves. You click on this add. If you've added before, you just click edit. So you click on add, it will bring up something like this. Curve editor. Curve ID is 1. Then under flow, put 600. This is page 5 now, I think. Page 5. Under head, put 150. Why? Because we got 130. So let's assume that loss is 20. So if I go to pipe pump, I'm finding the pump that has a head of 150 feet and a flow of 600. The maximum flow in the network is about 200. So let me provide something for 600. Okay. So after doing that, I will click on any cell. The pump curve will come up.
Sorry, excuse me, sir. What is this unit of this 600 flow?
The same unit we are using, gallons per minute, same unit on the drawing.
All right. Okay.
So if you just click on any cell, it will show you the pump curve. Every pump runs with the pump curve. Some of you who are familiar with pump, the higher the head, the lower the discharge. The higher the discharge, the lower the head. So that is pump curve for you. Okay, I'll click OK. Now I'll double click on this pump. Here they say pump curve. I'll write 1. Remember, under what I designed, the ID was 1. I'll put 1 here. What I'm telling the system now is that if you want to run this pump, run it with that pump curve that I have designed, that have an ID of 1. I'll press enter. I go again. I come here, I go to curve, I click add. It opens a space like this for me. I'll design it, put 150, put 600, it's in your manual. I'll take note of the ID here. The ID here is 1. I'll click OK. I'll come and double click the pump, and I'll put 1 here. So what it means that this pump will reference pump of 1 to run. So I will go to the curve and define the parameters of the pump. I'll press OK. So now we have designed our reservoir. Double click the reservoir. These are reservoir. Only head is what we need for reservoir. Reservoir does not need any other parameter if not the head. We have designed our tank. This is our tank. You can leave it at default. Okay, there's a place to define tank. Let's go there.
Sorry, sir, can I ask one question?
Go ahead, please.
The higher the head, the lower the discharge. Please, can you explain this? Is it that the higher the head, the lower?
It's a rule in pumping. When a pump, if you have a pump that can pump a higher head, the discharge will be slower. If you want it to pump, it's like a pipe. If you hold a 2 inches pipe, if you want that water stream to go very high, you press the mouth. That's lower the discharge. It will give you more pressure. It's a natural thing. Mechanical engineers know that one.
Okay, it's all right. It's okay. That's what I'm trying to get. Okay, it's all right.
So
on
I'm
my
trying
tank,
to
on my tank property, the maximum level. Did you, sir? Are you the one that changed it to 7 and 5?
now look at this pump. Don't be confused. Check what's
see.
the manual. Let's use what is the manual. Sorry, we'll be on the same page. Go to page. Yes. Where did they define the tank? There's a place for tank. Okay, go to page 4. The last paragraph, the one before the table. It says for the reservoir, enter elevation 700. For the tank, enter 830 for each elevation, 4 for each initial value. Then 60 for the diameter. So tank diameter is 60, please. Then initial value is 20. Maximum value is 20. And minimum level. Initial level, sorry, 4. Minimum level, it didn't define, but you can put minimum level 1. Last week, I told us that it's not good for tank to be at 0. So the minimum level is 1, the maximum level is 20, and the initial value, the always normal value is 4. We discussed it last week. So look at my tank parameters and put your own. So I've defined all the key elements in this network. The pump parameters have been defined. The reservoir has been defined. Are we together?
I can't find this information on page 5.
On page 4. On page 4, the paragraph before the last one.
Hello, sir.
Before the last paragraph.
Okay.
Middle paragraph. Towards the end,
Yes,
before you see certain link property. Before certain link property, you see it there. Page 4. Go ahead, sir. You have a question. You have a question, sir. We are listening. Let me say that some of you will not master this thing in one day. If you master it one day,
diameter we are defining is the diameter of the pipe that is connecting to the tank.
Is 10.
The diameter has given us 60.
The diameter, the last diameter connecting the last node to the tank is 10. The one following it is 12. Then the one.
So that means that this tank, tank is cylindrical in shape.
The diameter we put 60 there now.
Then this is tank property. Tank property, diameter of the tank.
So what putting 60?
60 is the diameter of the tank. We did tank design last time, 60 feet. We did it last time. That's about 20 meters. How to design a tank, is a cylindrical tank. The diameter, the height, and everything. We did it last week. So this is diameter of the tank. This is tank parameter. Look at the heading, tank parameter. Tank property, sorry. Any other question? Okay. Now you go to page Okay, so we should save our work. Page 5. Paragraph 2. Saving and opening project. So you say we should go here, click Save As, and then save your project to the name. What name can we give it? Let's give it cohort 3. Cohort 3 layouts or whatever. I'll give it a name. Save it in your folder. Save it where you can remember it. I'll save it. So if the computer goes off, I can still recall it. So we have saved the project. Now, the last paragraph, page 5, running the project. He said we now have enough information to run a single period or steady state hydraulic analysis of our example network. To run the analysis, select project, run analysis, or click the symbol. If the run was unsuccessful, then a status report window will appear, indicating that what the problem was. If it runs successfully, you can view the computed results in a variety of ways. Try some of the following. Are you with me? So I think I've defined everything. So I will run my program. Let me run. Run was successful. Everybody run your program. Click on the symbol for run, or you go to projects, run analysis.
Mine was unsuccessful, though.
Okay, so it will give you a report. Where did it tell you? What did it show you? It will tell you where the mistake.
Error 206, undefined curve.
Okay, so you didn't put curve. You didn't put one under pump curve. You did not put one under pump curve. Go click on your pump.
Okay.
Go to under pump curve. The pump did not see a parameter to run with. So the pump is not functional.
Okay, I should put one.
Not just one for putting one. You are putting one because you went and created a pump curve. Did you create a pump curve? I created
a pump curve.
But you didn't tell the pump. You didn't reference it to the pump. So go back and reference. So here it says curve ID 1. Curve ID 1. I click OK. I now went to the pump and then I put 1 under pump curve. Telling the pump that I've created a curve. Use that curve to run.
Sorry, this dialog box for pump curve.
I should tag it along with the one that I created because my own label is curves 1.
Go back to pump under the 1.
I should not put curve 1. I should just put that one.
Oh, just 1.
Okay.
Sorry, this dialog box for pump 1. Where do we click it from?
No, we click on the pump. It will give you the dialog box. Or you go here, you open here, click on pump, and then click on properties.
Sorry, where? Go where? I'm not seeing your cursor.
Okay, right click on the pump. Right click on it and say properties.
All right. But this is when you have already defined the pump as 1. I'm looking for that dialog box.
When we are setting the system, we set pump 1. We say let every pump answer pump 1. Let me pause this.
That's what I'm saying. Where do you set it?
So after running this, you go to map view. This is for a single state running. You click on what parameter do you want to watch.
Sorry, sir. You said the total head.
Then here you put velocity. And then you could see those parameters. I think this will help some of us who have mistakes. You can see that these are exactly how it is. These are the heads. These are the elevation of the tank. So I'm viewing elevation against velocity. I can view elevation against flow.
So you said that the head for the reservoir is 700, and it's 700. Yes, I imputed 700. I don't know where the problem is. So
Hello, sir.
Yes.
Like some of us, if you click reservoir, for example, and you want to add the elevation, it's not showing for you
You
to
know,
enter the
you put
elevation.
reservoir. This is symbol for reservoir. It's not reservoir that you added. As reservoir, this is symbol. If you double click on
There's
it,
a reservoir.
it will show,
There's
sir.
a reservoir that is added, but
Then
it's
let me
only
added it twice. Can you delete one? Maybe it will show you head. Put 700 under head.
yes, that one is added, but the elevation is not there.
Head and elevation are the same thing. There's no elevation. You cannot put head. In reservoir, you define elevation with head as head. It's the same word. So you cannot be looking for elevation again. Head.
Okay, sir.
Please, sir, this indications showing red, blue, and I think this is I don't know.
I can't hear you, please.
Anyway. Can you hear me? Hello,
No,
sir.
I can hear you now.
Okay. I said these indications showing red, blue, and I think purple. Are they indicative of anything?
Yes, they are indicative of anything, but you need to set what they indicate. So now, if I go to my pipe, this is the pipe legend. This is the elevation legend. I will right click, and I will set limits to them. Okay, I can say if the flow, let me say, the first I will do here, watch me, I'll say reverse column. I'll click on reverse column. What I'm telling you now, if the flow is below 25, show blue. If it's between 25 and 50, show 50. If it's between 50 and 75, show yellow, and so on and so forth. So you can change these values. So they're indicative of something. I can also reverse it. The other one, it did not be the other way around. Okay. I've reversed the color now. So it means high flow should be, low flow should be red. So with this, I can know where there are low flows in my network.
Yes.
So the most important thing here is to learn how to right click on this legend and then indicate the upper limit and the highest upper limit. We're all engineers. Here you define so that when you plot this map, somebody from a glance can see where the problems are. That's the essence of computer. Remember, I said computer is for simulation and modeling. So what we're doing now, what I'm showing you now is a model, is a one single state model of our network.
Okay, sir, thank you. So in a case where you maybe see a red indication that you have put there to indicate low flow, how do you maybe correct it if you want it?
Then you know you need to increase discharge, or you need to you now troubleshoot. You now troubleshoot.
Okay, you go back to the parameters.
So it is not successful.
Sorry?
I'm successful now. I'm happy. It's successful. I'm happy, sir.
Okay, I've seen the mistake. Okay. Now,
yes.
Remember to view results. You go to map view. There is data view, there is map view. Now, if you look at this place, if you check the if you check at this place, say day 1, 12 a.m. So this is the status of your network at day 1 by 12 a.m. But as a modeler, as an engineer, you need to troubleshoot your water system over a period of time. Like if you are drilling a borehole, we usually recommend 24 hours of pumping testing. If the aquifer can pump water for a period of 24 hours without non-stopping, based on a calibrated discharge, you calibrate the discharge to be equal to the recharge. So as the well is recharging, you are discharging. If that well can run for 24 hours, then that well will never fail. That is what we call pumping testing. In modeling, when you define your model, you must run your model on different scenarios. You must run your model with different boundary conditions. You must run your model by changing some certain internal parameters. The idea is to see the flexibility, to see the robustness of your model. You don't just design something and, oh, this thing will carry 20 people. How about if tomorrow it carry 40 people? Will it fail? I designed my train for a 10 hours, 10-year return period. How about if a 100 return period rain comes? Will it just wash off all my design? That is where simulation comes in. So we have modeled our systems, but we're going to simulate it over a period of time. That brings us to what we call extended simulation. So go back to data view. Go back to data view. Or if you want to go to map view, you say no view. Under links, you say no view. No view, no view. It will just go back to normal. So everybody do it. Say no view, no view. So I'm not viewing anything. Under map. So no view, no view. Now I'm going to run an extended simulation. So you get that on page 6, I guess. So go to page 6. Are you with me? Added a time pattern, page 6, second paragraph. We have run a single steady state period. Now let us add a time pattern. What is time pattern, gentlemen? Time pattern is what we call peak periods. For a typical water design, there are about 2 patterns or 4 patterns in a day, residential area. Between 12 in the midnight and 6 a.m., everybody is sleeping. The water consumption has a pattern. Between 6 in the morning and 12 in the afternoon, there's a pattern. Between 12 in the afternoon to 6 in the evening, people have gone to work. There's a pattern. From 6 in the evening to 12, there's a pattern. Now, these patterns are defined by what we call peak periods. If some of you remember, in some places, once it's 7 o'clock, 8 o'clock, the water is not running well. And once it's 7 o'clock, 8 o'clock in the night, the water is also not running well. Why? Because these are peak periods. So those of us live in Abuja or Lagos, these are Lagos people. There are periods you cannot travel on Lagos traffic. If you want to go to work, you go to work before 6 o'clock. Once it's 8 o'clock, 7 o'clock, hold up everywhere. Those are what we call peak periods. The same thing applies in water consumption. In Abuja, those of you that live in Kubwa and Lugbe, you will know that if you want to leave your work, if you leave your house between 8:30 and 9 o'clock, when civil servants work time, you're in trouble. There's hold up everywhere. Or 8:30 to 9:30, let's say. You know, those are when civil servants are going to work. Everywhere is blocked. So what we do in residential areas is that we define time patterns. When you define those time patterns, it's to see whether your network can perform during peak periods. Like I said, an engineer must design his model work under severe conditions. So if you go to page 6, paragraph 2, he said adding a time pattern. So number 1, he said we should go to options. So we're going to create what I call 6 hours time pattern. 6 hours time pattern. I'm going to create it. Okay, so I'll go to my whiteboard. If I go to my whiteboard, I will show you that in a 24 hours period, I can define 4 different patterns. So in a 24 hours period, if this is a 24 hours period, I can define 4 patterns. This pattern, this pattern, and this pattern. If you come here, you find out that here is 0 hours. Here would be 6 hours. Here will be 6 hours. The next is 12 hours. The next is 18. And the next is 24. So for instance, all of us know that this period now, the water consumption might be at 0.5. Like everybody is sleeping, consumption is low. At this period, the consumption will be at high by, let's say, 30%. So I say 1.3. Then at this period, it will come down to normal. If everybody understand me, during afternoon time, water is just there running, no pressure on it. But in the evening, it can go higher to 1.5 or 1.2. So if I define this thing now, as it is now, it will now show me how the water is moving. So let's go to the practicality of it and see how it is done. No need to say too much. So I'll go back here to my screen. So to do that, you go to my browser, you go here, you go to pattern, click on pattern. Click on pattern. You see there's no pattern here. So you click on add. Add. So when I click add, I'll come here. The first 24 hours pattern, I'll put here, I'll put 0.5, which is that first pattern. Here, I'll put 1.3. Say demand is high, but it's up by 1.3. Here, I'll say, demand, the people are coming to house, they are going house, they are going to school. Some people are going to work, some people are going back to school, around between the hour of 12 to 6. So pattern remains the same. Then in the evening, people are coming back, another 1.2 or 1.5, whatever you feel like. So this is a typical pattern for the case. So people are sleeping, only stand up, you go and nobody's bathing, nobody's cooking, nobody's watching car. So the demand can be up by half. While during peak period,
so I can't see pattern on my own. I can't see pattern, sir.
Please go to here, click pattern and click add. You see it here. You can't say you don't see pattern on your own. There is a software.
Go to map. I should go to map.
Go to your browser here. Click on pattern. There's pattern here.
Okay.
Oh my goodness. Come here and click. You see
data,
pattern. There's pattern
data,
there.
not maps. Data, not maps.
Okay, data. Go to data browser. Click on pattern.
There's no pattern.
View results. So if you click on this pattern, everybody do this pattern now. Make sure you get this.
So it says you go to data.
Go to your map browser, data, under data tab. Open it. And you see pattern. P-A-T.
Okay, I've seen it.
It has always been there.
Add.
You click on it and click add.
Okay. I've clicked it.
Sorry,
so
sir.
What again?
No, I'm just saying so that you don't draw us too back. You know we are 25 in number.
I've added the what again?
How about these parameters here? How about these parameters?
My own is not showing like yours. It's not showing like yours.
Because you didn't add 0.5 here. If you add 0.5 here, 1.3 here, 1.0 here, and then 1.2 here, it will show like mine.
Okay. 0.5. Oh God.
Please mute. Okay. We are running up in the next few minutes. We're already on page 6. So next is page 7 and we close. then I will send us video. I will send us video where I use another exercise, another template I use it. So it's not left for you to watch that video. So if you don't have anything doing today, please, you are going to spend the next 2 hours on your own. I'll send you the video to watch. Please, outside our own video. So
Please,
that
how come my own
exercise.
time period is starting from 11? So my time period is starting from 11.
Drag it back. Maybe you are dragging front, or maybe
You need to scroll to the front, to the beginning.
In a quick class like this, if you don't understand something, you can just skip it.
Are we still recording?
Skip it.
Recording
I
is
don't
on.
understand.
Recording is on. Okay, madam, just hold on. Let's finish so I don't draw us too back. Let's not lose time, right? Just calm down. So after adding this pattern, I'll click OK. Then I want to run this simulation based on this new pattern. So what I will do, I will now go and create what I call pattern time step. I'll come here, just like in page 6. I'll go to options. When I go to options, I'll go to times. I'll click edit. This is where all of you are going to have me problem, but listen to me. After times, you click edit. You now go to duration. You type 72 hours, which is like 3 days. Now, if you look at pattern time step, you know that thing I said 6 is 6 hours. So under pattern time step, just change it to 6. That's all. Just put 6. That's the only 2 things you change. Just put that pattern. Otherwise, I'm telling him to change after every 6 hours. And I'm telling him to run for 72 hours. You can put 24 here. Or let me put, because the number is 22. So let me leave that for 22. So 72 hours, and then you put pattern time step, put 6. That 6 means change the pattern every 6 hours. That's why I said 0, 6, 12, 18, 24. Is everybody here? Put 72 here and put 6 here. Even if you have not created the time pattern step, just do this one. Put 6 under pattern time step. The pattern I created, what is the time step? The time step is every 6 hours. Then leave everything the way it is. Let it start by 12 a.m. and let the duration be 72 hours. The duration was 0 because we are simulating, we are doing simulation now. So we have done the modeling, want to simulate over a critical period, peak periods. I'll click enter and I'll close it. Then I'll go back and run it. That place will run it.
What are we expecting to happen every 6 hours out of 72 hours?
You will see that the pattern, show me what the pattern is like. Show me what the network is. Just go and run the network again, successful. Then to see what you have done, you now go to map and click, let's say, base demand, and then click flow. Have you discovered that something will come up here, something that looks like a DVD player? It wasn't there before. And if you see time, you'll discover that I can pick any time of the day up to a period of 22 hours and choose exactly what the system is saying at that point. For instance, I can come here and I choose, I say, I want 7 a.m. in the morning. It will tell me exactly how the system is performing and where are the high points and the low points. Did you get it? I can right click on my legend and I'll say reverse color. Oh, sorry. It will show me where it's red. Show me where is everything. Just come down. Now, why do I need this simulated time? It will give me a result of 72 hours. After here now, I'll click on play, for instance. It will be changing. The value will be changing. It's telling me at every time. It's on 18 hours now. This is what the system is. This is what it will be telling me per minute how the system is performing. And that is what we call simulation. It will simulate it. But that is not the end now. Listen, I'll pause it or I'll stop it. I'll go back to my browser. I will now produce a report. And that is complete. Okay. Now, that's the last page. Listen, all this we are doing, what is the output? You come to project, report, under reports, you say full report. You find a place and save it. So I'm saving it here now. Cohort 3 layouts. I'll say save as. I've saved the report. I will now go, I will exit, I'll use my browser. I'll go to where I saved it. You must know where I'll go to my documents. I'll go to Ethernet. Sorry. I'll go to Ethernet projects. I'll see the reports. Cohort 3 layouts. Look at it. I'll right click on it. And I'll say open with Word. Open with Word. It will open a report for me. Look at my report. Look at the report of what I've done. And this report is about 52 pages because I'm running for 3 days. So can everybody open, just create a report. Let me just see. That's the end of this place. Video support will follow, but I just want everyone to get to this report page. I'll do it again. I'll do it again. I'll go to reports, full reports. I'll go somewhere, let's say desktop. I'll save it, report 1 or report 1 in anything. How do I open the report? I'll go to my desktop where I save the report. I'll look for the report on my desktop. Report 1. I will right click and open it with MS Word. I look for MS Word and I open it. In a few minutes, can somebody open these things and just tell me I have done it? I'm okay.
Yes, it's 50 pages.
Good. I will do another one with 24 pages, 24 hours, and that will be less. So how do I do it? I'll go back to my Ethernet. I'll go to Times again.
Engineer, done, but I have a question.
I'm coming, sir. I'll come here, I'll change to 24. Still the same time pattern. I won't change anything. I'll still leave it at 6. I will run again. Successful. I will now come here. I will create a full report again. I will call it report 1. Report 2, sorry. With report 2. So under report 2 now, I will go back to the desktop. So this one, how many pages now? Still high, 18 pages. So it's understandable. This is 18 pages. So here, this is the report you submit to your client. This report, I would not have time, I would have studied them. This report will give you a report of everything you have done based on, this is 00 hour. It will give you 24 different, this is at 1 hour. These are the link value. These are the node value. And so on and so forth. So because of time, we might
It's 18 pages.
I'm looking for my screen. Okay, this is my panel screen. Now, just for information, Ethernet is so limited that you need to produce some of these things and give to your clients. So what you do, you screenshot them. and put them on your wall. Please, it's too short. Another way to do it is to go to edit. You say, select all. It will draw a map around it. You now go back there again and say copy. Sorry. Copy to. You say copy to. You now open a Word file or anywhere you want and paste it. Please, that's how to, only the result is extracted. Someone raised his hand. What's your question, sir?
Okay. All right. The question is this. I saw that some of the flows are negative. They're negative. You're showing minus. Is there any particular reason for that?
It's backward flow. It's not a problem. It's flowing. That is when the tank is supplying. So it's moving in the opposite direction. It's no issue, sir.
My own question, sir.
Yes.
Yes, sir. The pipe, when you are editing the property of the pipe, is it supposed to be closed or open?
Whether closed or open, it doesn't mean anything. It's irrelevant.
I have a question.
Go ahead.
And then my question is that
I can hear you, sir.
Okay, sir. My question is that, for example, now, if in our inputs of the pipe parameters, and then one has made mistake, because I see that this simulation now depends all on what we inputted. The simulation depends all on what. So now, if we had inputted a wrong diameter of pipe, maybe for example,
you double click, change it and run again.
The software has the ability of flagging it up that this thing, the pipe size in this location is not correct. From what values
no, sir.
on
No, it
our
does not
map
have that.
browser
No, it's not AI.
to determine that?
No, it does not have that parameter. What you do is you observe, you study your result, and you check where the velocity is too poor, where the flow is too much. You like now, I can come here, I can change these pipes now to 8. All I need to do is I'll go back and run again. Anything you change, you run again. That's just all. And then I can run again, and then I can go back to map, and I'll view again and check, like pressure. Now let me view the pressure.
So you said select copy to.
Yeah, select all. So you can screenshot everything. Then there's another thing I want to show us. Table. You can go to table now. You would say on that table, you go to columns. You choose what you want to choose. All these things are in the video I'll give you. You remove the ones you don't want to see. Like initially, these are 5 parameters I want to see for my table. I'll click OK. It will produce a table, a junction parameter for me like this. How do I use this? If I come here, I click on here. Or I click. Sorry, if I click on this one, I'll come here. I'll say copy to. It will copy it. I'll open Excel. I will paste. I will Excel. You know, Excel is very powerful. So you can see I can copy these things and paste them in Excel. Then there I can start doing operations. Now you might not see the relevance in this one, but let me do it with pipe. And you see how relevant it is. Listen, I will close this one. I will come to table. On that table, I'll say links. I'll click the second one, links. I'll go to columns. I'll say I want to see the length. I want to see the diameter. I want to see the length. The unit loss, I'm not interested. The frictional factor, I'm not interested. The reaction rate, I'm not interested. The quality, I'm not interested. The status, I'm not interested. I will say, okay. It will give me all the pipe parameters. Then I will click in between here. So it will highlight all of them. I'll go to edit. I'll say copy to. I'll say it has copied to clipboard. I will now come to Excel. Under Excel, I'll open another sheet. And I'll say paste. It will write me all the pipe parameters. Assuming these pipe sizes are the same, from here, I can come here and I will say, I can come here, I will say sum all. It will give me the total length of all the pipes. So the total length in my network is 37,500. So that will help me do my BEME or do my estimation. Assuming these pipe sizes are the same, I can also come here and I'll know the diameters. So with this, you can move from Excel to APANET. The idea is to make you a well-rounded consultant. Because like I said, if you're an engineer, you don't know how to use Excel, there's a problem. You don't have Excel because you can copy all the results from APANET, put them in Excel, and then they become your consultant. Are we together? So we were short by 20 minutes. Because
sorry, sir, I can't see my pipe diameter and length on my table.
Okay. You will go here, you go to table. Once you go to table, you now go to this column. You go to the second tab and then you choose what you want to see.
the table where you are playing your cursor to get to the table.
I choose what? What would
under
I
standard
choose?
menu, I say hover around it, there's a table there. Or under report, you say table report. Go to report. Under report, you go to table. Under report, table. Then you filter what you want to see on the table. If it's a pipe I want to see, I'll click on the second one, say link. I'll now come here and I'll choose length. I'll choose diameter. I'll choose the things. I'll remove the unnecessary things I don't want.
Okay.
That will bring confusion. I will now say okay to give me those parameters.
Okay.
Then I'll click between the row and the column. It will highlight. I'll now go to edit and I'll say copy. So it has copied it on the clipboard. Then when I now go to Excel, I'll click on a column, on a sheet, and I'll paste it. Now, let me tell you something. If I do this exercise and suddenly you master everything, then something is wrong. You only master it, you have gone through it once. That is the principle of learning. That's why when you learn something for the first time, don't complain, oh, I didn't get it, I didn't understand it. No. Nobody does it. I mean, these are things that